Nice to be here. I would like to thank the Alephium team for organizing this wonderful event. It's quite hard getting 60 people in a room together, coordinating all this. And on top of that, we're all developers. So, this is crazy that, we're all here in one room. So, yeah, thank you so much, the Alephium core team and Maud especially for organizing this. She's on top of everything. So let's start by discussing the app development throughout the UTXO chains, because Alephium is quite unique because we have Bitcoin, of course, and there's no smart contract support. Then we have another blockchain like Cardano, like top 10, top 20, which is UTXO, but it has smart contracts. Although it has contracts, it's completely different landscape compared to how development is on Alephium. So we're going to start by discussing the basic building blocks, and let's talk about what UTXOs really are. So UTXOs, of course, stand for unspent transaction outputs. So it's the outputs of the previous transaction you did. But what exactly does this mean? It's just a bunch of words. So Bitcoin pioneered this model. I like to think of UTXOs as the exact digital analogy to cash. Just as we use cash for building blocks for real-world transactions, UTXOs are the exact same for Bitcoin transactions. So, yeah, you can see, like a simple diagram showing how if you would pay for coffee, how the $10 bill would get split up. So let's go into more detail. So let's say we have one person A, and you're trying to pay person B. So consider a transaction where you need to pay a party $30 while you have a $100 bill. In this transaction, you need to spend the entire $100 bill. So you lose the entire $100, and then you would receive $70 as change. So person A, then person B would get that $30 that they wanted in the first place. Pretty simple transaction. Everyone's familiar with how change works. And now UTXOs and transactions on Bitcoin are nearly identical. So a UTXO is a data structure where value is stored. Now, getting back to our example, we must transact using Bitcoin. So, same parameters, the receiving party, person B, now gets 30 Bitcoin and you get 70 Bitcoin change. All you got to do, look at this exact thing, change the dollars to BTC. Exact same thing. And another dominating model is the account-based model, pioneered by Ethereum. And here, addresses are viewed as accounts itself, just like how you have a bank account. And all accounts are aggregated balance. So there's no need for any UTXOs. You just have a value where it's much simpler, and sending funds reduces the balance of one account and increases the balance of another in the perspective of a node. So this is all managed by a global state. So UTXOs, so in my opinion, UTXOs dominate over the account-based model. It's scalable. So since UTXOs can be processed independently, multiple transactions can be executed in parallel. Additionally, UTXOs are stateless by nature. So each UTXO can be only spent once, ensuring that no two transactions affect the same UTXOs. So this really reduces compute required. And next we have privacy. When wallets are created, you can see that the mnemonics are analogous to master keys. Each addresses generated from the mnemonic, you can think of it as an isolated individual key. And from a public standpoint, UTXOs appear to be owned by specific addresses. However, transactions can be signed using this master key. So one master key can sign for all child addresses or all isolated addresses. So the public sees it as isolated, but for you have control over any address you generate. And this allows for good privacy, since users can either selectively use UTXOs from specific addresses that they own, or combine UTXOs from multiple addresses in a single transaction. And this enhances privacy by either obfuscation or cherry picking. And next we have security. as transaction inputs and outputs are recorded, it's really easy to authenticate a UTXO. So we have the next generation of UTXOs blockchain, which extend the model that Bitcoin pioneered to allow for decentralized applications to be built. So let's take Cardano and Ergo, for example. Cardano's UTXOs has everything Bitcoin has, plus one small detail. You have the ability to store any arbitrary data through a structure called datums, and the ability for scripts to own UTXOs itself. And Ergo is very similar. It has the same thing, but instead of datums, it has 6 open registers. And other than purely storing data in these data structures, it allows for scripts to access and evaluate arbitrary data. So yeah, let's go through all these structures. So here we have the structure for Cardano. So we have the blockchain, and we can get a single address. So a UTXO or an eUTXO in this case can be owned by that address. And then within that UTXO, we have a datum and we have a script. And then the script is very interesting because it's much more different compared to account-based model, and I'll get into more detail in the next slide. But essentially for now, all you need to worry about is all the script does is it evaluates to true or false. It's a proposition. And then when you actually execute the transaction, you can include additional context in something called the redeemer. And that's the structure for Cardano. And Ergo is very similar. You have a box, and instead of having datums, just think of you having registers. So each box can have up to 10 registers denoted as from R0 through R9, and 4 of these registers are mandatory and contain specific values. So here you see R0 contains the actual value of the box. This is the value, the coins that you care about. Then R1 contains a serialized guard script, and all this means is that it's the logic behind the contract itself. So in Ergo, it's very cool because addresses are just smart contracts itself, in the core. So in here, you just have a guard script, and the smart contract, all it is it's like a wallet address. You can think of it like that. And if you want a smart contract, all it would be is the hash of whatever script in the same guard script area. And yeah, it just has to evaluate to see if the UTXO can be spent or not. Then R2 declares tokens, native tokens, and R3 declares some context data, so like creation height, the transaction or the UTXO ID, etc. Then the remaining R4 through R9 are just any arbitrary data can be stored, and smart contracts in the guard script has access to that context. So yeah, this is the basic data structure of the next generation, Ergo and Cardano. So here we can get into the actual code. So 1 second. All right, so in the UTXO model, contracts operate fundamentally different from the traditional Web 2 programming or account-based smart contracts. So as mentioned earlier, all logic is evaluated as propositions, which must resolve to either true or false. And these Boolean values determine whether if a specific transaction is permitted to spend the respective UTXOs. And this approach provides an unambiguous way for contract logic within the UTXO framework. And the consequence of this evaluation simplicity means that contracts are not self-executing. And this is a huge difference compared to how people are familiar with Ethereum or even Alephium. So it cannot be expected to send a UTXO. You can't just send a UTXO with one coin, for example, to a contract. And if you have contract logic which says you must split this UTXO amongst like 10 other addresses or 10 UTXOs, you can't just send value to the contract and expect it to automatically be distributed. Rather, you need to build the transactions on your own, which spend the UTXOs within the smart contract. Then each of these inputs are evaluated against their own respective contracts to determine if they resolve to true. So here we can go through a very simple contract on Ergo, and I chose this because the syntax is much more smaller than Cardano. So here we have a contract which checks that you have the right hash or you have the right pin to spend the UTXO. So it's just guarded by pin. There's no addresses guarding it. So that means that anyone can make this transaction. So you have so here we define an output, and this is just an output UTXO. And here we grab the hash of the whatever value is in the R4 of the output. So R4, remember, it's an arbitrary data value which you can put on your own. So here this just means it's a byte array. So we grab the byte array from the R4 register of the output UTXO, and then we hash it using the Blake algorithm. And then the input hash, all this means is this is self. So this is the contract UTXO self itself. And you grab the array of bytes from self in R4, and it's already a hash, right? Because you don't have the actual pin value. You check through hashes and passwords. So you have the input UTXO's data, and you have the output data which you create on your own. So like anyone trying to spend this UTXO. So here self is what has the coins, and you're trying to extract value from. So here you compare if the self UTXO's value is the same as the output value that you built yourself. And if that's the case, this will evaluate to true. And if this evaluates to true, you can spend the UTXO. So you can see how much more complicated it is to explain this logic and how it's fundamentally different from the self-executing you're related to on Ethereum and Alephium. So in order for these contracts to be processed, you need something else. And so this is up to, so you have to so after these are evaluated, so I mentioned that. Okay, so it would be ridiculous to expect users to build this or even websites to do this on its own, or expecting wallet developers to like integrate every single smart contract logic or even basic contracts like templates. It's too much. So rather it's up to the dApp developers to create something called off-chain executors on Ergo and Cardano. And these executors in theory are quite simple. They scan the blockchain to see if there's any UTXOs sent to contracts. So contracts, just like Ethereum and Alephium, they're just addresses, right? And you can check if an address has any value in it, or UTXOs in this case. And if there are any UTXOs, it builds the transaction according to the contract parameters and submits it. And this runs independent from whatever the users do. So an analogy to Web 2 could be a backend server or some indexer. It's just independent, runs regardless if there's any users or not. And from a user standpoint, this seems automatic. Like they'll see I'm sending X funds to a contract and the contract is distributing it automatically. But this is not the case because there's a bot which runs it. So a significant drawback of this model is the complexity of writing these executors. This process introduces substantial development overhead, and bugs in executors can potentially halt a dApp's functionality, even when the underlying contracts itself are working. So your funds would be safe. So for example, again, I have a contract which distribute funds. I send value to that contract. Okay, as a user, I send value, but the bot doesn't exist, or the bot's like turned off, or there's some bug. My funds are still safe. There's absolutely nothing wrong with the protocol. However, since the off-chain bots are not running or some bug is found, for example, maybe there's like an overflow bug in the off-chain bot and just it halts, doesn't do anything, the user will think something's broken, like something's wrong, and then the bot has to be fixed. They don't care, or they won't even understand what an off-chain bot is. They'll just think something's wrong with the blockchain, and they'll think that there's limitations and all. So this is a huge problem because there's bugs that can be caught, and it's a huge learning curve for developers to write this, and it can be time consuming for onboarding developers in the first place. Like not only do you have to write contracts, you also have to write all this supplementary infrastructure. It can't just be done, and then you test this infrastructure and there's bugs and all sorts of stuff. So going off this, we have the newest generations of blockchains combining all the benefits of UTXO and account-based model, such as Alephium. So Alephium implements stateful UTXO, known as SUTXO. An account model makes smart contracts easy to write. The programming is similar to the Web 2 world. Furthermore, managing contracts within other contracts is allowing for incredible modularity. This isn't as simple to do with UTX or extended UTXO blockchains. However, with the account model, there are risks when managing assets, as we see constantly with Ethereum. The constant hacks and drains on Ethereum-based protocols are proof of this. Because the developers might not see it, but there's compiler bugs issues. Like many times, the hacks which occur on Ethereum are very low-level compiler bytecode issues that, of course, the developers like us, we don't see, or nor do we have time to care about it, right? We expect the compiler to do its job and for us just to follow documentation and write the protocols that we're supposed to. But these compiler bugs, ruin the whole protocol, and we might not see it. And then, of course, you can't just explain this to the users. They're not going to care if it's a compiler bug, if it's your bug. They're just going to see that they lost their money. So this is a huge issue. And on top of that, Ethereum or EVM, the whole account-based model, they don't have native assets. They're just contracts managing these assets. And you're just updating a value in a contract for balance. That's all it is. So, and we have the UTXO model in general, which is very secure at managing assets, but it's lacking flexibility and expressiveness, as I just explained the contracts. So Alephium's model is in two parts: immutable and mutable. The immutable handles values which always remain constant, such as digital assets or any value. And mutable states generally revolve around contract logic. For example, you have a DEX, the price points change if you're doing a swap and so on. So this isolated structure for handling digital assets allows for inherent checks at the contract compiler level itself. It explicitly ensures asset operations are secure. Specifically, this is managed by Alephium's asset permission system. So the asset permission system, known as APS, is a solution over the flaws of the token approval system on Ethereum. So I'm sure a lot of people already have experience on this, but just to go over it, whenever you interact with a new dApp, especially which uses ERC-based tokens, you have to do approvals letting a contract spend your tokens. And the problem with this, especially from a user perspective, perspective itself, they have to do multiple wallet signatures. That's confusing to explain to them. It makes them, whatever they're trying to do, much slower and more frustrating. And not only is the user experience poor, it leaves room for assets to be drained by approval from a malicious contract. So all these contracts, usually, I don't know how it's done now, but back when I used to play with Ethereum a few years back, it would always ask to spend the max amount of contract, like some huge number that's really close to overflow, saying that, hey, you must approve this amount of tokens to be spent. And that means that if you accidentally approve a malicious contract, sure, in that instance, it looks correct to you. Everything, it does its job, it does what it claims. But in the future, since it took that approval, anytime hacks can be done and your entire balance can be drained just because of this approval. That's it. And again, user doesn't know or nor care. They just see their funds are drained. They won't understand. And the APS allows this asset movement to be explicit for both development and users. So users know, just like Ethereum, that they're spending some assets or tokens or whatever. And the really good part is also developers know that their function is also using money. They can't just accidentally drain your money. It's very obvious. They have to do these obvious annotations here. So for example, we have these functions here in the Alephium smart contracts. And here, you have to specifically annotate saying that you're using assets. If you don't do this, you cannot take users' funds. So it's incredibly obvious from a developer standpoint that funds are being used. So they can't accidentally do anything malicious or do anything at all wrong. And unlike Ethereum, only one transaction manages both approval and movement. So the issue with user experience is solved. So development experience is unparalleled on Alephium from my standpoint. All development has to worry about is front end and smart contracts. Unlike the UTXO paradigm I just explained, everything is self-executing. Interacting or transaction building for contracts is consistent for any contract. It's just a set of pre-generated code. You just write the contract, you generate the TypeScript code, and you're good to go. It's all like the same pattern. So you really truly just need to worry about smart contracts. And the node manages, transaction building as it sorts out, which transactions to pick and all. Unlike with UTXO, where you have to build each specific individual UTXO, you have to specify it. In fact, when I was working with Alephium on the hackathon, I think I messaged Cheng asking him, "Hey, how do I send funds using UTXOs? Like, how do I call the UTXO and organize?" And he's like, "Oh no, you just call this function to share values. Very simple." And I was blown away. I'm like, this is a UTXO blockchain, and you don't need to like build your own transaction. I was like very happy with that. So I have my own dApp on Alephium under Phoenix Finance. So this is what I built during our hackathon. So this is a degen finance game called HODL Alph. So stick with me here. The concept is pretty straightforward. Users deposit ALPH to our bank contract to exchange for HODL ALPH tokens. And this starts out at a 1-to-1 ratio where there are no fees. And again, this is an asterisk because for simplicity, of course, I collect some developer fees, but that does not affect the protocol whatsoever. So we're just going to assume that. So it starts at 1-to-1 ratio where there are no fees, and the ratio stays consistent given there are no withdrawals. Redeeming HODL ALPH for ALPH is what causes this discrepancy. So if users want to redeem, they must pay a small percent of redeemed ALPH, which stays within the bank or within the contract. Initially, people will lose money if they exit. However, this fee that they pay, this goes towards increasing the ratio of ALPH to HODL ALPH. So after a few people exit at a loss, one HODL ALPH token could redeem to 1.5 ALPH, and users then would be further incentivized to leave because they are already in profit or they're breaking even. They'll leave, and them leaving itself will snowball further and grow that ratio, because when they leave, they still pay a percentage, and that percentage yet again increases this ratio and creates a very nice snowball effect. And the theory behind this game guarantees that the worth of HODL ALPH always either stays the same or always goes up relative to ALPH. So the protocol itself, so I'm not talking about the smart contract, the protocol proof itself guarantees this. Of course, there can be bugs with smart contracts. I'm pretty confident in mine. However, from a protocol standpoint, impossible for the price to go down. And this is very fun game theory in my opinion. Like, this is not serious. It's just for fun, because for people, the external economic factors are really the price of Alephium to fiat or USD, right? So recently we had a small dip in the Alephium price, and what happened to the protocol? I had after a few days after launch, I think I had around 50 or 60,000, something like that in ALPH. It was maybe worth $180,000, I think, in value. I don't remember the exact amount, but it was worth a lot. And then Alephium price dipped quite a lot in the next few weeks. And what happened was a lot of people exited because they're unsure. And unfortunately, people don't even read this. They see I make money and they just put money. They don't care. So a lot of people are like, I don't know what the fuck is going on, and they just leave. And the problem with it, and what this did, is people who actually read it, they were rewarded because the price went up. And now one HODL ALPH is worth, I think, 1.2 ALPH, and they understand it and they're in the game and just put it really well to a test. Now again, we're going to see what happens when Alephium shoots up. What's going to happen? Are people going to get that profit and pull out and further increase the price, increase the ratio? So it's a very nice game theory going on here. And it's important to mention that new users can join and hodl too. So it's not like traditional assets where you have to buy first and profit the most. Right now, you can buy HODL ALPH for the ratio of 1.2 ALF. So if you pay 1.2 ALF, you'll get 1 HODL ALF. You can buy here again, and then you have to wait for the price to go up to break even point, because you have to consider that rate, that small fee you have to pay to exit. So that's really your break even point. And the cool part is this is very easy to port to native assets, which I will be releasing very soon. And you can do this with any native asset. So I think meme coins will have fun with this. I mean, again, it's nothing serious, just a fun game to play. And let's talk about the origins of Phoenix Finance. So initially, this game, it was developed on Ergo by a different group of developers. I had no involvement. Unfortunately, there was a severe exploit on this, and this caused the contract to be drained by a good actor, a good developer that we're friends with. And the problem was, it wasn't the issue with contract. I mean, it was, but it was poorly implemented contracts. Just it was a person who was inexperienced who did this. And myself and another Phoenix team member rewrote these contracts, hardened it for security, wrote the off-chain executor and front end for this. This took about 2 months of time. I did this almost exactly a year ago now. And then I re-implemented this for Alephium Hackathon, primarily because I wanted to do a small project that I understood pretty well, and nothing too serious. And I worked on this myself because my team member was very busy with other things. And I not only learned the entire Alephium development, but I wrote all contracts and this complete end-to-end thing in 2 weeks. 2 weeks compared to 2 months on a different UTXO blockchain, which I already had experience for the last 2-3 years. So that's how much better the development experience is on Alephium. And yeah, I mean, that concludes my lecture on the state of development. I personally think Alephium's really leading the way, and we'll definitely get a lot of adoption for this, because that's the number one thing. If we don't have anyone to come here and build, like, what's the point of this, right? It has to be accessible for all. Thank you.